Yes, let me know, is my screen visible? Yes, anyone unmute? Actually, my screen is it is covered. Okay, full screen mode is there. Just unmute and say yes. Yes, anyone?
Yes, sir,
Yes.
visible.
Okay. So yesterday we discussed about some ARC instructions. Okay, so these are the registers. Okay, so these are the ARC total 32 registers. Okay, to store the data along with that program status register, program counter. Okay, these are the registers. Then there are some instructions we discussed. This is the main instruction, add instruction, add content of source. That is two data is required, no input, and this is the destination register. Okay. Then the one more type of addition instruction is content of register, content of register and constant value. It is like a percentage R1 that contains some 10 value and constant is 12. Okay, तो दोनों का addition कितना होता है? That is 22. तो R3 में 22 का value रहेगा. R3 register contains. Then there are some other instructions. Load instructions. Load the register. Load the, this is the destination operand. Load the register from the content of a memory location specified by the registers. Okay. And store instruction means store from the register to the memory location. यहाँ से content of register to the memory location pointed by the registers. Store from registers, load to registers, load to registers. Okay, this is the same. Okay, load means what? Load the registers. Okay, load registers, and here store from registers. Store the data. Store from register. Store from register to the memory location pointed by the registers. Okay. This is simple example where you are loading the X from content of R1, loading the Y2 from content of R2, then adding the content of R1, R2 and result storing in the R3 register. Okay. Then R3 में भी result है. Then that R3 we are transferring to here. Content of R3 to memory location pointed by the this Z. Simple. Then similar to that, there are some other branch related instructions. Branch always. Okay, this is called as branch always. Branch always means branch and address. When the condition is true, okay, the program counter will specify the address of the next instruction to be executed. BA and some label. When the condition is true, it will jump to that particular location. Okay, so program counter, it will specify the address of next instruction to be executed. Address of next instruction. Branch always, branch on 0, branch not 0. These are some branch related instructions. So along with that, these are some summary, the main important instructions. Okay, you can say some important uh, like here it is a load instruction. Load the register from the memory. Store a register into the memory. यहाँ लोड में क्या करते हैं हम, लोड द रजिस्टर. स्टोर में स्टोर फ्रॉम रजिस्टर टू द मेमोरी, into the memory. Set high. This set high is called as load the 22 most significant bits of the registers. And these are all memory. This is logical related instructions. Set high and CC or CC or and CC SRL. This is are the mnemonics. Okay, mnemonics means instructions. As you know, like 8085 instructions, 8086 instruction, no? Similar to that, these are the ARC processor instructions. ARC processor instructions. ARC processor instructions. Okay. Then arithmetic add CC. Here they are specified only very few instructions. Like means they covered here all memory related instruction, logical related instruction, arithmetic. Then these are all control related instruction. Call, subroutine, jump, branch equal, branch negative, branch on carry, branch overflow, branch always. These are all some control related instructions. Okay, control branch instructions means once the condition is true, it will jump to the particular location. Then yeah, same the description. This is load a word into the register, store a word into memory. There are some other instructions. LDUB means LD means load. Okay, LDSB load unsigned load unsigned byte. Okay, fetch a byte. Load LDUB means unsigned byte. LDSB means load signed byte. LDUH load unsigned half word, full word. Okay, word means 16 bit. Word means the 32 bit. Okay, 32 bit, and half word means 16 bit. These are some the instruction: add, subtraction, and or logical related instructions. Okay, and yesterday we discussed the format also. Now yeah, okay, these are some format means how we specify the ARC related instructions. ARC processor instruction format. Instruction format. Okay, so here you can see I think you can see the position here. This is the 31st, 30 30th. So 00 to 31 means it is a 32-bit register. So all the registers of size is all the registers of size is 32 bit. Okay. So the format means set high is a logical instruction. Okay, logical. Okay, set high. It is a logical instruction. Branch format call. Call means it is also a control. Branch and call are same type of means control related instruction. Control branch. Okay, branch and call. Call means call particular address. Branch, if the condition is true, it will jump to particular address. Then arithmetic instructions. Then memory instructions. Okay. So here you can observe for each instruction there is a 2-bit reserved for the OP. OP means opcode. So this OP will decide what is the which type of instruction it is. This OP, these 2 bits are there. 2-bit 31 and 30, 31 and 30 for all instructions. Okay, for all instructions it will decide 2 bits. Okay, 2-bit will decide, like suppose if it is 00, then it is a set high or branch related instruction. Here it is fixed, it should be 00, then it is called as set high or branch related instruction. If it is 01, okay, the 2 bits 01, then it is a call instruction type. Then 10, if it is a arithmetic. Arithmetic means addition, subtraction, multiplication, any type arithmetic instruction, that is 10. Then memory means 11. Memory related instruction is 11. Okay. Then after the OP of code operation, then in see set high and branch, the 2 bits are same 00. Now to differentiate these two, there is one more code is called OP2. OP2 that comes in only these type of instructions, OP2. So if OP2, that is position the 24th, 23rd and 22, 24, 23, 22, if this particular bit position, if it is 010, then it is a branch type, and if it is a 100, then it is a set high type. Branch and set high. Okay, it is fixed. Okay, if the particular OP is 00 and OP2 is 100, then it is a set high type, and you need to remember the position 22, 23, 24. Okay, so set high OP, OP2, and there is a immediate here 21, from 21, 00 to 21 means 22 bits, 22 bit reserved for the data. Okay, immediate data, and there is a destination register, that is the format of set high. Then branch related, see here 30th and 31 are 00, 29 bit is also 0, and OP2 is 010, and for condition there are 4 bits are reserved. For condition 4 bits are reserved, 25, 26, 27, 28, 4 bits. Then branch means it is address, right? Once the condition is true, it will jump to the particular address. So to calculate that address and all, it 22 bits are reserved. 22 bits are reserved. 22 bits are reserved. Okay. Then call address. Okay. Call address. Call here the 2 bits 01 that specifies the call instruction, and displacement 30 bits are reserved. 30 bits are reserved for the address. Okay. Then in arithmetic 10 that specify 31 and 38 bit. Okay, this particular arithmetic type of instruction, the 2 bits 30 and 31, if it is 10, it is arithmetic type of instructions. Okay, if it is 10, 30th and 31 bit. Okay, so arithmetic means 2 registers are required. So that is 14, 15, 16, 17, 18. 5 bits in the source register. 0, 1, 2, 3, 4. 5 bits here. Okay, 5 bits for second register. So content of these two are added and store it in the destination register 25, 26, 27, 28, 29. So this is the how it reserved. Okay, means it is fixed. The content of register location will be fixed 14 to 18. Okay, and the 19, 20, 21, 22, 23, 24. So these 6 bits are reserved for the OP3 operation. OP3 means here what happens? Arithmetic means there are various instructions are there, arithmetic and logical instructions. Arithmetic means 10 that specify the arithmetic. So in that, the OP3 will specify it is which type of instructions: add CC, and CC, or CC, or shift right left, shift right. Okay. So it is based upon the OP3 code. So you have to remember this OP3. OP3 if it is 10, OP3 if it is 10, 10 means in the case of OP arithmetic ये 10 रहा तो इस OP3 suppose अभी add instruction का क्या है 10401400 means ऐसे 011234 ऐसे total 6 bits. Okay, total 6 bits. So in this way it will result. And then another type is like here these are all default 0, and here the 13th bit it specifies whether it is a type of register type or constant type. Okay, in the first case 2 registers are involved, source register and RS1, RS2. In second case 1 register and constant value. Here the constant value. CMM13 is the constant value. Okay, source register 1 and constant value. So similar to that memory also it load and store. Okay, so please let me know if you are understood, or shall I repeat? I hope you understood the contents. Okay, means here it is a format, means because these are all 32-bit registers, and how it stores the data, like for arithmetic related instruction, branch related instruction, logical related instructions. Okay, it mainly depend upon the instruction format. So these two are the opcode specifies which type of instruction it is, 2 bits, 30th bit and 31 bit. It will specify whether it is a branch related or arithmetic type of instruction or memory type of instruction. Okay, it will specify. Then it depends, like for example in arithmetic there are two registers are involved, so this particular location is reserved for RS1, RS2 and the destination register. So similar to that, another case is that source 1 then constant value, okay, and store the result in a destination register, then memory related instructions and all. Okay, so any doubt, just let me know. So here you need to remember, and there are very few instructions they are mentioned here. They are not covered all the instructions. Okay, and in the one more 32-bit register is program status register. Program status register. This one. Program status 32-bit register where negative, zero, overflow, carry. Okay, 23rd bit, 22 bit for 0, overflow 21 bit and 20 bit for the carry flag. So that is the instruction format. Then pseudo operation. Pseudo operation in ARC processor is pseudo operations are the instructions to the assembler. Okay, pseudo operation means we are giving some instructions to the assembler. They are not part of the instruction set architecture. Means they are not instruction. Instructions means here these instructions: add, subtraction, this add, call, jump, L, branch, equal, branch, not, negative, and all. These are all branch related or some ARC instructions. So pseudo operations means it is a instruction to the assembler. Okay. So this is the one pseudo operation dot equ. So it is equivalent to x dot equ hash 10, means it treats the symbol x as 10. Okay, the pseudo operation is, this is the pseudo operation dot eqx. So how we can use dot equ hash 10, means we are assigning some equal. Okay, we are assigning some value, that is 10 value. Dot begin means to start the assembling operation. Dot end to stop the assembling. These are some pseudo instructions that we use to use in ERC processor. In ERC processor, pseudo operations. Then .org. .org means the location starts from the this particular address, whichever address. Okay, if we specify 4000 .org means it change the location to particular address. DWB, reserve a block of 25 words. Global y use another, means this particular y variable that can be used in another module. Z is defined in another module. Okay, we specify these keywords dot global, okay, dot extern, dot macro, end macro. Okay, define a macro operation. and instruction and if condition, dot if. Okay, if the condition dot if we use in the, well, means we are writing a pseudo operation, means pseudo code, we can consider it as a pseudo code. I think you know the pseudo code means step by step instructions. Dot end if and dot align means round the location counter up to even multiple of 4. Okay, so these are the some pseudo instructions. Means, see, in this particular your syllabus they are not given complete all instructions. Okay, very few important pseudo operations they are mentioned. Okay, and synthetic instructions. Many assembler will accept the synthetic instructions. Okay, I hope you understood this. Pseudo operation means it is some statement, step by step instructions. Okay, it is similar to the pseudo code. Pseudo code. While pseudo code we write for the any program. Even your placement also, like for some of the recruitment company test, Capgemini and all, they give the pseudocode. Even this TCS, persistent, they give the pseudocode, and you need to predict the output. So these are the synthetic instructions. ERC processor, synthetic instructions. Many assemblers will accept the synthetic instructions that are converted to actual machine language instructions. So here you can see this is the instruction, the instruction, how it is generated, means converting the instructions into the machine language instruction during the assembly. So not RS1 comma RD. So the instruction generated is in this form: X nor RS1 percentage R naught comma RD. See, not means it's a complement, one's complement operation. Okay, so you no need to bother about this. Okay, it is just like they are given. So the in this particular chapter is you just remember the instructions. Okay, ERC processor instructions, and in that also they are not mentioned all type of instructions, but very few instructions they are mentioned. So these are all important instructions. Okay, that's all. The main intention of this unit in your syllabus is to introduce ARC processor instructions. Okay, ARC processor instructions. Like you have gone through the 8085, 8086 processors. Okay, so similar to that, this is a 32-bit register, 32-bit processor. And that is all about ARC processor. And there is one more concept comes in your, that is a memory hierarchy. This is very important. Okay, so the memory hierarchy. Okay, so here based upon the size, see, I'll take a different color. Okay. So memory hierarchy means here the CPU register, the small size memory, small size memory. Memory size is very small, and here the size is large. Storage storage size of storage size is large. Okay. So CPU small means registers. Okay, registers to store the data. Okay, here to store the data. Okay, that is we use the registers. Registers means very small size, but here it is costly. Okay, it is costly. Then after the the registers means it stores like a 16-bit data, 32-bit data, like okay, 32-bit data or 64-bit data. It is very small size. Then comes the next memory, that is cache memory. Cache memory means here the size is considerably larger compared to register. Okay, the size is large compared to the register, and it is also fast memory. Okay, here that is static RAM are involved. Then main memory, that is your primary memory. Okay, dynamic RAM. Okay, that is your main memory. Like see your suppose you can consider your cache memory is 8 MB and your primary memory is like 256 MB or 512 MB or 1 GB or 8 GB RAM. 8 GB RAM. Okay, 8 GB RAM and your cache memory is 8 MB or 16 MB we can consider. Okay, and it is in terms of KB, the register. It is KB, it is in terms of 8 MB, it is in terms of 8 GB RAM, and your magnetic disk and store. Okay, it is in terms of GB, optical disk. Okay, the like hard disk and all. Okay, your pen drive hard disk. Okay, the size is larger, like 1 TB, but here it is less costly. Okay, the size here it is the registers are more costly. Okay, I'm unable to write here properly. First comes the register, then comes the cache memory, then comes the main memory, then comes the your like consider hard disk only. Okay, then you can consider your cloud, like we can. Okay, here the register small size, storage space is small. Here large space. Okay, but here small size means here more costly, more costly, because here the speed is faster, data access speed is faster, right? The data access speed is faster for for smaller memory, but here in large memory, in hard disk and all, if we consider, it is slow compared to that. The data access speed is slow, and here it is less costly. It is less costly. Okay, means if you want faster access, you need to pay more. Okay, like cache memory and all. Okay, it is faster memory, but it is costly, and the size is very less. But if you want more storage of the data, then the speed is decreased. Okay, speed is reduced, and there are some techniques are there how we can improve the speed. Okay, how we can improve the speed. So this is a hierarchical, means like here in the triangle shape. Okay, triangle shape means here the this particular size is very small, size is larger, size smaller, the fast data and the access speed is faster. Okay, and smaller size, the costly. On cache memory it is costly, but the speed is faster. But for large memory, the speed is slow. Here the speed, the data access speed is slow. The data access is slow. Okay. Okay. So this is all about your third unit. Okay.